Bob here, Chopper Bob Customs. Working on the 58 DelRay. I cheated a little bit. I've kind of gone through and done some things off camera just because they're kind of tedious, and I didn't want to have the camera tying me up. So what I did was I went ahead and got all the air conditioning fittings tight, evacuated the system, ran it for about an hour with the vacuum pump to draw it down and to hopefully boil any moisture out of it. And then I closed it off, turned the vacuum pump off, and let it sit overnight. I had 28 inches of vacuum when I turned it off Monday night, and Tuesday morning when I came back out to check it, it still had 28 inches of vacuum, which is a pretty good indication you haven't got a leak. I went ahead and put a can of Freon in it just so it would have a can in it, and so that's ready to start charging it once I get the engine running and turn the AC on. Put oil in it, put antifreeze and distilled water in it. I always use distilled water, regardless of how good your tap water is. It's got minerals and stuff in it that can foul up your cooling system, and so your best bet is to use distilled water and good quality brand new antifreeze. So it's got that in it. And charged the battery up, and basically then started doing a little bit of testing. I found some things that, I mean, anytime you're doing something like this, you'll run across some things that you just have to take care of that you either didn't think about or missed your catching them. One of the things I did was make sure that the fuel pump worked, turn the key on, made sure the fuel pump worked, and then immediately checked for leaks. And two of the fittings were leaking, and it was a total brain fart on my part. There's a lot of fittings on these fuel lines because of the nature of them, and I missed two of them. They were snug, but they weren't tight. Got them tightened up, and the fuel leak went away. So, but there's some other things that I'm going to go over today that I got to take care of, and so I thought I'd go through them, and if everything works out the way I hope it will work out, we'll start this thing at the end of this video. So let's start with looking at the electrical system. If you saw my video, I posted a short one yesterday about how not to wire your 58 DelRay, or any other car for that matter. This car has had some electrical issues, and hopefully they've been addressed. But let's go over that. Anytime I do electrical work on a car, I'm always cognizant that, you know, I can make mistakes. I'm not perfect, and so I like to make sure that when I hook things up, I'm not going to be welding. I'm going to be actually testing the rest of the car out. So one of the first things that I do is the negative cable is always the first to come off and the last to go on. And the reason for that is you put your wrench on the nut and you slip, and if you're on the positive terminal and the negative one's hooked up and that wrench touches the ground, or you've got you shouldn't wear rings, period, when you're working with the battery, but a lot of guys do. If you got your ring on and it's up against the wrench, it's on the positive terminal, and you make contact through that ring, you're going to lose a finger. So if you're on the negative terminal and the wrench hits the ground, it doesn't do anything. I mean, it's ground to ground. There's not going to be any current flow through the wrench, your ring, your finger. And so the negative is always the first to come off and the last to go on. Negative ground car, obviously, we're talking about. If you got positive ground, it's just the opposite. But so the first thing that I'll do is I'll put the positive terminal on, make sure that it's good and secure, and then I'll take my test light and I'll hook the lead up to the negative terminal on the cable, and then I'll take and touch it to the negative terminal on the battery. Now, Yeah, you can see the light coming on there. What that means is there's a completed circuit. So now we've got an issue where we know that something is connected and will draw power from the battery. If the light did not come on, that would indicate that there was no connection anywhere in the car that was turned on, and therefore you know that there's not going to be amperage flowing. But now we know that something is turned on. We don't know what it is because this is an extremely low resistance or extremely low current draw light, and so it only takes a little bit to make it come on. So it could be the radio, which has a feature that draws power from the battery intermittently when the car is completely turned off to keep the clock running and that sort of thing. This car also has the Phytech EFI, which can draw power to keep itself memory taken care of, maybe. Not exactly 100% sure about that. But there's a lot of electronic things in a car nowadays that will draw power. So we don't know. It could be a grounded positive battery cable. And so you kind of need to do a visual inspection to make sure that you don't have any large gauge wire that is grounded out somewhere. If you've done that, then chances are pretty good that you've got a low amperage draw. So the next thing you would do then is get your multimeter and set it to amps. Now some of the small ones you can tend to be risky. This one right here has a 20 amp maximum current rating, and it is unfused, which means that if you go over 20 amps, you're probably going to cause some damage. But 20 amps really on a car, with the exception of the starter and maybe a faulty alternator, you're going to be hard pressed to get 20 amps to flow through most of the wire. So what you do is you go to the 20 amp circuit and you plug it in, and you select amps direct current and you go to 20. And so basically then your scale will read from 0 amps to 20 amps. So let me see if I can set that someplace where you can see it. Now, the negative goes to the terminal on the battery, the positive goes to the connection on the cable. And what happens when we touch this is that it immediately jumps up to about 1/10 of an amp, and then it drops down to 0.08. So basically what that's telling me is that something like the radio is probably making an initial draw on this, and then it's going away, which would be what the radio would do. So now we know that this is going to be okay to hook up. And when you hook it up, you'll see a small spark, and it'll go away, and then you will have the battery hooked up. And I need to go get a wrench and snug that up a little bit. But that basically is a quick check to make sure that we don't burn the car to the ground. And if you watched the video yesterday on how not to wire your car, there can be some concerns on this car because of the way they wired it. But right now, we're in good shape. So with that, we're going to go to the next problem that I found, which is underneath the back of the car. Alright, I'm underneath the back of the car now. I put 10 gallons of gas in the tank so that I could check the fuel pump, check for leaks, and get it ready to start. When I turned the key on to check the pump The pump ran. Obviously, it pumped some gas on the ground, not much. It was a very minor leak, but I got that sorted out. But the other thing that happened was I looked at the fuel gauges. This has got 2 fuel gauges in it. It's got the stock gauge and it's got an odometer gauge. Obviously, because they were having problems getting the fuel gauge to work on this car, I wanted to make sure that I checked it because I figured I would have a problem with it. And sure enough, it pegged both gauges on full, actually beyond full. So, of course, I was in panic mode. I called Rock and Robin up because I was at a loss as to why it would peg so hard that the odometer gauge is actually pegged way past full and it won't come back down. I'm hoping that that can be salvaged. But he said, well, you've got infinite resistance. And so what that means is that somewhere between this sending unit, which is supposed to have no resistance, 0 ohms, to 30 ohms resistance, there is an open circuit that is not grounding the negative side of the gauges, and therefore is causing it to peg the full. And so what I've done is I'm underneath here with my ohm meter. The first thing I want to check is to see if the fuel gauge actually has resistance. Since it's about 10 gallons, it should be somewhere between probably 10 and 15 ohms. So I've got this set on 20 ohms because I did use the MetroPack connection back here. I am able to disconnect it and check directly against the sending unit. And let's see if I can get this around where I can see it. And I've got an open circuit. I did not want to see that. No. That means that apparently I have a defective sending unit. Let me see if I can get up in here and get the rubber boot pulled back. Make sure that my wire is not the issue. So, I've got an open in the sending unit. Make sure I've got a good ground. Yep, I've got a good ground. Oh, I did not want to see that. That means that 10 gallons of gas has to come out of it, and I have to pull the tank down. Well, so I guess the moral to this story is you should check your sending unit before you put the tank in and wire everything up and put gas in it. I had a couple of oil issues. When I went to put oil in the engine, pulled the breather out, put the funnel in, thinking that this had probably been modified. It had sort of been modified, but it basically just had a couple of small holes in the bottom, which did not allow the oil to pass through fast enough, and so it puked oil out on the ground. And then when I went to pull it out, I also found out that it was hard and cracked. So I had to get a new one. And the first thing I do when I get one of these, there's a flap in here that if you're just using it as a breather, that's okay. But if you're going to be using it to put oil in it, I always go in and I cut that flap out completely. I don't know whether you can see in there or not that basically I have removed it to allow oil in there. Truth is, if you've got blow-by bad enough that it's going to force oil up through here, you probably have other problems. If you're only using this as a breather, that's fine. If you got an oil fill someplace else, use it. But since this is the only place to put oil in it, I've gone ahead and cut that out to allow oil to flow through there. And if you have a baffle inside your valve cover, I would probably go ahead and cut it out completely. But this does not have a baffle inside of there. And so what I'm going to do is I'm going to put it with the opening, the one closest to the top of closest to the breather is going to go down to the bottom. That way it should allow drain back and prevent oil from coming back up out of the breather. And so with that, now the breather is installed. It's not a very tight fit, but I think what I'm going to do I just slipped an O-ring around the grommet, and that tightened it up so that it's not sliding around. And that's all it took. Another oil-related problem that I had was I put 4.5 quarts of break-in oil in it. The engine had already been run on an engine stand at the engine builders. So basically, when the engine builder replaced the stock pan with the chrome pan, he drained the oil out and gave it to me. I went ahead and put it back in. That's when I found the problem with the grommet. And then when I went to check the oil, thinking, well, at worst, it's going to show that it's on the add line. It didn't show up on the stick at all. And so I'm trying to figure out what the problem is there. And there was a couple things going on. First off, the add line on the stock dipstick is right here, and so it has basically another quart and a half to show of oil in the crankcase, whereas the replacement, the custom one, the add line is right there and the stick only goes to right there. So if you're a little bit more than a quart low, you're not going to see any oil at all on this dipstick. The other thing is, if you line up the location on the block where they go into, what you'll see is that the full line is about 3/8 of an inch below the full line on the custom dipstick. So basically what that's telling me is that this is too long, and so what I'm going to do is I'm going to go ahead and shorten this braided stainless. This is a PTFE line braided stainless, so it's a slightly different type of stainless steel, braided stainless steel line. However, this is not what you would find on a PTFE line. You would have a different fitting than this. This one obviously is for little to no pressure, because basically you shouldn't have any pressure in this dipstick. If anything, it should be negative pressure from the positive crankcase ventilation. And so what I'm going to do, out of the way, is I'm going to go ahead and take this apart and show you what I've got here. Okay, on an actual pressure braided stainless, you're going to have something similar to this, PTFE line braided. You're going to have something similar to this, but what you're going to have is a little ferrule that most people call an olive that goes in there and actually allows it to seal. This one, baby. They want to put anti-seize on this one. Yeah, I need to put anti-seize when it goes back together. Clean that up a little bit, but I think what happened was it was on just a little bit too far that time. What you have basically is, instead of the rubber liner, it's got the PTFE liner, and that goes down on the cone shaped part right there, and then the braided stainless locks it down. And like I said, on an actual high pressure one, this right here is a brass ferrule type situation, where it conforms and gets a good seat, whereas you don't really need it on this. And there are guys that say that you have to use a cutter on these. I know on my 41, I did exactly the same thing that I'm going to be doing here, and on the power steering line. I'm going to shorten this 3/8 of an inch, and that should get me ballpark on it. I mean, it should improve it quite a bit. And and what I'm going to do here is I'm going to go ahead and shut the video off, because I've got some cleanup that I'm going to have to do on the nail threads, and so I'll come back when I'm ready to reassemble this. Okay, got it cut off, got it cleaned up, checked it, real close, probably within a 1/16 of an inch. Basically, you just kind of force the PTFE down on the cone, you work the nut down over the mess until you start catching threads. If this were a pressure fitting, I would probably go ahead and tighten it up until it was tight. Since this is not a pressure fitting, I'm tightening up so it looks good. But it's basically there. And now let's take a look and see how we compare. And I don't know whether this will come through on the camera, but basically the full line on both of them are essentially in the same spot. So that should take care of that. However, it probably will not still register, since the add line is right there and I only have that much of the stick left. But we'll put it in and see how it works. Not so much as getting it running as it is to make it roadworthy. The owner wanted to get the park lights and the turn signals working on the front. If you caught my short video on how not to wire a car, you kind of saw what was involved there. But what we have now is we have park lights then we have operating turn signals. So that has been taken care of. Okay, so it is getting really, really hot out here in the shop. We're in the big week, the 100 plus degree temperature week here in Oklahoma. And so I'm pretty much not working very late in the day. Got a metal building, no insulation, no air conditioning. And so I'm about to the end of my ability to withstand the heat today. So the last thing I got taken care of today, the horn didn't honk. Now, to give you an idea how a horn works, when you have a horn ring, like this car has, and you push it, what happens is it makes a connection between the ground and the wire that runs out of the steering column. So when you push the ring, basically you're completing a circuit to the ground. Unfortunately, as you can see from this one right here, there's something wrong inside of the steering wheel, and so it does not function correctly. So what somebody has done is they have added a push button under the dash, and that's okay. I mean, it is what it is. And then from there, what happens is, and I don't know whether I can get down low enough to show you, but the way this fuse panel is laid out, the top row is battery. This row right here is ignition, and this row right here is accessory. Well, this fuse right here is the horn fuse, that 20 amp fuse. So to diagnose the problem, the first thing I did was I hooked the battery up directly to the horns out under the hood. And the left one works, the right one tries to work. So it could be that it's just a matter of time using it, that it'll start working, get some road vibration to loosen things up, or it could be that it just flat needs to be replaced. But knowing that the horns work, then I came inside to check out the circuitry in here. And the first thing I checked was the fuse, and the fuse was good and it had power to it all the time. Then the next thing to check is the relay, which is right here. This is the horn relay, and what it does is the fuse goes to the 30 terminal, which is the oddball one. That's, in this case, it's vertical, and supplies power to it. And then it also goes to, it's either the 87 or 80, no, it's either the 85 or the 86, the coil wire, and gives positive energy to the coil that pulls the points, so that closes them from normally open to normally close. And then the other side of that coil goes to the horn button. So in this case, it comes up to here, and this has a wire that goes to the ground, and it has a wire that goes to here, so that when you complete the circuit, you've got the hot normally here, and then the button provides the ground, the negative over here, which then provides a pathway for the wire from the fuse out to the horns. Well, I came in and started checking it, and got to a point to check the button, and when I did it, the horn worked. And so I don't know what I did to get the horn working, but it does. It may have had a bad connection at the relay, and pulling it out and putting it back in got that cleaned up, any corrosion cleaned up, and is making contact. I did pull the button down. It may have been a loose wire. It may have been some dirt on the points in the button. I don't know. But for now, it's working fine. And it's like I told the owner of the car, I said it's really hard to diagnose a problem that no longer exists. So He's going to take it, try it, and if the horn keeps working, we'll know that I managed to dislodge something that was preventing a good connection, or if it stops, maybe I can diagnose it at that time. So, with that said, I'm going to be doing a little bit of pickup, and then I'm going to call it a day because I'm about to melt. I've got the fan running behind me. It's blowing hot air. But the next steps on this, tomorrow I'm going to be out here pulling the tank down to see if I can figure out what's wrong with the sending unit. And if it's something easy, like a loose wire on the sending unit, or maybe some bad contact, needs contact cleaner on the resistor inside of there. It's a rheostat actually. Maybe I can get it working and get it back in the tank and back in there tomorrow. Otherwise, I'm going to have to get a new sending unit, which may take some time to get here. And then beyond that, I need to get the engine started again. It started right up, idles. I didn't run it long. I just wanted to make sure that it was going to work. But I'll need to get the timing set, and then I'll need to get the AC charged, and then visit with the customer on the next steps. So we're making progress on it. It's 2 steps forward and 1 step back, which is a lot better than 1 step forward and 2 steps back. So keep watching. Hit that subscribe button. Like the videos, please. Comment. I've been talking to some folks about chopping old Plymouths on the comments. So at any rate, let me know what you're thinking. And for now, Chopper Bob out.